Hey everyone, and welcome to This Explainer. Today, we're creating a completely safe, stress-free space to conquer quadratic equations together. Look, I totally get it. For so many of us, math can feel like this stressful, jumbled alphabet soup of random letters, right? Especially when you're gearing up for board exams. But I want you to just take a deep breath. For the next few minutes, think of me as your personal, private tutor. We're actually going to look at the real world first, before we even touch a single formula. We are going to demystify this whole topic in simple, friendly, everyday English so you can walk into that exam room feeling absolutely confident. Let's get started. Okay, so let's jump right in with a pretty cool question. Have you ever actually wondered how a satellite dish works? Or, say, how a rocket flies? You know, we so often think of math as this abstract thing trapped on a dusty chalkboard. But it's not. It's actually the hidden code behind literally everything in our physical world. Whether you're calculating the arc of water splashing in a fountain, designing a massive suspension bridge, or just figuring out the path of a baseball you just threw, these mathematical patterns are everywhere. Before we even think about equations, just look at these curves for a second. The really graceful upward path of a rocket blasting into the sky. That very specific bowl-like curve of a satellite dish. The curve of the lenses in the glasses you might be wearing right now. Even the stopping distance of a car when you slam on the brakes. They all follow this beautiful, totally predictable pattern. Notice how they aren't straight lines. They're curves. In mathematics, we simply need a way to describe that exact curve so we can, build things safely and accurately. So let's meet the quadratic equation. Those real-world curves we were just looking at, they're described by a very specific mathematical phrase called a quadratic equation. And now that we know what it looks like out there in the real world, let's break down its secret code, step by step. I promise, the logic behind this is actually really beautiful once you see it. So here's the DNA of that curve. ax squared plus bx plus c equals 0. We call this the standard form. Now, I want you to think of x as our mysterious shapeshifter. That's the unknown variable we're usually trying to find. Meanwhile, a, b, and c, they're just regular, friendly real numbers acting as our anchors. They're what give the curve its exact width and position. Now, there is literally only one golden rule you need to remember for this whole formula to work. Our leading number, a, can never be 0. Why? Well, just think about the logic for a second. If a was 0, then 0 times x squared is, well, just 0. The x squared term would completely vanish. And without that squared term, the math entirely loses its curve. It just flatlines into a boring straight line, and boom, it's no longer quadratic. That x squared, that's exactly what gives the rocket its arc. All right, level 1, spot the imposter. This is an easy one. Let's warm up with a quick little exercise. We're going to see if we can spot which equations are truly quadratic and which ones are just imposters in disguise. Let's read the question together, nice and calm. What's given? We're given the equation x minus 2, all in brackets squared, plus 1 equals 2x minus 3. Okay, what's asked? We just need to check if it's a quadratic equation. So, step by step, let's just expand the left-hand side. The x minus 2 squared becomes x squared minus 4x plus 4. We add that little 1 on the end, bringing us to x squared minus 4x plus 5. Then we just gently move the terms from the right side over to the left to balance the whole thing out to 0. When we simplify, we get x squared minus 6x plus 8 equals 0. And here's the crucial part. This matches our standard form perfectly. The a is a hidden 1, the b is negative 6, and the c is 8. So yep, it is indeed a true quadratic equation. Okay, pay really close attention to this next part, guys, because this right here is the absolute most common trap students fall into during board exams. Exam writers, they love to play tricks on your eyes. They'll give you something that looks totally quadratic right out of the gate, but actually isn't. Or they'll give you something that looks like a scary cubic equation with an x to the power of 3, but it magically turns out to be quadratic. And this example brilliantly illustrates that trap. Let's look at what we're given. X times the bracket x plus 1 plus 8 equals x plus 2 times x minus 2. At first glance, you see those x's multiplying and you immediately think, x squared. Boom, it's quadratic. But wait, let's follow our golden rule. Always simplify first. When we expand the left side, we get x squared plus x plus 8. When we expand the right side, we get x squared minus 4. Now, watch what happens if we try to pull everything over to the left side. The x squared minus x squared equals 0, completely cancel each other out. We're just left with x plus 12 equals 0. Because our a term became 0, our curve completely flattened out. It's an imposter, definitely not quadratic.
Moving on to level 2, the triangle problem. Let's call this medium difficulty.
You are doing fantastic so far. Now, let's see how this builds by translating a real physical geometry problem into our new quadratic language. And I promise you, it is way easier than it looks if we just take it one step at a time. Here's what we're given. A right-angled triangle has a hypotenuse of 25 centimeters. We're also told the difference in lengths of the other two sides is 5 centimeters. So what's asked? We need to find the quadratic equation to figure out the exact lengths of those two sides. Now, a pro tip, whenever you see a geometry problem, sketch it out immediately. Let the smaller side be our shapeshifter, x. Since the difference is 5, the longer side just has to be x plus 5. Now we get to use a tool you already know and love, Pythagoras' theorem. Side squared plus side squared equals hypotenuse squared. Let's set it up. X squared plus the bracket x plus 5 squared equals 25 squared. All right, let's expand this calmly. We get x squared plus 10x plus 25 equals 625. Combine your like terms, and we're looking at 2x squared plus 10x minus 600 equals 0. Now, do you notice how all those numbers are even? We can actually divide the entire thing by 2 just to make it cleaner. And look at that! We arrive right back at our comforting, familiar standard form. X squared plus 5x minus 300 equals 0. Beautiful, right? All right, here we go. Level 3, the marble mystery. This is the hard one.
Take a deep breath. You're doing absolutely great. Now let's tackle a hard, actual board exam level word problem. But we're going to use our trusty logical framework. Do not let big blocks of text intimidate you. Here's the story. Given. Sridhar and Rajinder together have 45 marbles. Both of them lose 5 marbles each. The product of the number of marbles they now have is 124. Asked. Form the quadratic equation to find how many marbles each of them had previously. Okay, whenever you're faced with a paragraph of text like this, always hit pause, read it calmly, and simply separate exactly what the story is telling you from what it's actually asking you to find. Honestly, using a simple table is the absolute best way to visualize the before and after here. Let's say Sridhar starts with x marbles. Since we know they have 45 together, Rajinder must have 45 minus x. That's our before. Now for the after. They both lose 5, so Sridhar's new count is simply x minus 5. Rajendra's new count is 45 minus x minus another 5, which cleans up nicely to 40 minus x. Organizing your thoughts like this, it entirely removes the anxiety of word problems. Now for the actual math. We're told that the product of their new marble counts is 124, and product is just a fancy word for multiply. So we set it up, bracket x minus 5 times bracket 40 minus x equals 124. Let's expand those brackets step by step. We multiply our x terms, and then our numerical terms, being super careful with our negative signs, right? Once expanded, we combine our x terms together in the middle, leaving us with negative x squared plus 45x minus 200 equals 124. To finish this off, we just need to bring that 124 over to balance the whole equation to 0. Subtracting 124 from both sides gives us negative x squared plus 45x minus 324 equals 0. Now, technically, it's fine to leave it like this, but, mathematicians like things neat and tidy. We usually prefer our leading x squared term to be positive. So if we just multiply the entire equation by negative 1, which literally just flips all the signs, we get a perfect, pristine standard form. X squared minus 45x plus 324 equals 0. Just like that, you conquered a board-level word problem.
Let's wrap up with a quick cheat sheet and an exam trick. Huge congratulations on conquering those 3 levels. To wrap up this explainer, let's build a really quick toolkit you can take straight into your exam so you can solve these faster and with absolutely zero panic. Here is your 5-point cheat sheet. Number 1, memorize that standard form, ax squared plus bx plus c equals 0. Number 2, remember the golden rule, a cannot be 0. Number 3, if you ever start feeling stressed, rely on your visual real-world anchors. Picture that rocket taking off or the lens of your glasses. Number 4, whenever you see a word problem, draw a table and identify what's given versus what's asked. And number 5, always, always simplify fully before judging if an equation is quadratic or just an imposter. And exactly as promised, here is a surprise trick straight out of the textbook remarks that's going to save you precious minutes on test day. As the textbook remark warns us, you can quickly spot those imposters by using a technique called mental cancellation. When you're looking at a messy equation, just scan for the highest power of x on both sides. If you see an x squared on the left and an x squared on the right with the exact same coefficient, you can literally just cancel them out instantly in your head. You don't need to waste time writing out the full, tedious expansion just to realize the squared terms vanish. This mental check lets you instantly know if you're dealing with a straight line or a true quadratic curve. It is a massive time saver, especially on multiple choice questions. So, now that you know the hidden mathematical language behind the physical world around us, and you have the tools to translate it calmly and confidently, I have a quick challenge for you. Look up from your screen right now. Just take a look around the room you're in. Where else can you spot a hidden quadratic curve? Because these mathematical patterns are absolutely everywhere, just waiting for you to decode them. Keep practicing, stay calm, and I know for sure you are going to do brilliant on your exams. Thanks for joining me on this explainer, and I'll see you next time.